Good morning. Chapter 5, Lesson 4 is on page 219. We're going to be doing scientific notation. On the right-hand side, we've got a couple of things we have to remember. A to the mth power times a to the nth power. All we're going to do is add up our exponents. And for number 43, I'm going to tell you that there are 365.25 days in a year. The 0.25 comes in because every 4 years we have a leap year and we add that extra day. So we have actually a fourth of a day extra per every 4 years. So I use 365.25. Let's begin with number 25. We're going to multiply in scientific notation. Remember, everything is commutative, so we can always move things around. So I'm going to break this 7 times 10 to the 4th times 2 times 10 to the 2nd into their pieces. Oops, helps if my pen is working. So I have 7 times 2 times 10 to the 4th times 10 squared. Well, the 10 to the 4th, 10 squared, I'm going to have that to be a 10 to the 6th. That's a no-brainer. And I'm going to have a 14, 7 times 2. So my answer looks like 14 times 10 to the 6th. But remember, in scientific notation, our number always has to be between 1 and 9.9999. So we have to convert this 14 into a 1.4. And if we do that, we're going to have to add one more decimal place. So it's going to become 1.4 times 10 to the 7th. Remember, in scientific notation, all of our numbers in the part without the times 10 to the 7th always have to be somewhere between 1 and 9.99. So I turned that 14 into 1.4. I added one more 0 to it. Let's try number 43, estimate my age in seconds. Well, I'm going to use my age and you're going to use your age, and I'm going to tell you that I'm 55 years old. So let's get started. So I have 55 years. And I'm going to say there are 365.25 days in 1 year. And it turns out there are 24 hours in 1 day. And it turns out that there are 60 minutes in 1 hour. And it turns out that there are 60 seconds in 1 minute. So when we're all done, I think we're going to end up with seconds. And this is called dimensional analysis. I'm just going to highlight years divided by years, days divided by days, hours divided by hours, and minutes divided by minutes. And what I end up with is in just plain units of seconds. And that's what I was after, because that's what the problem was asking me to do. So I need to break out a calculator. So my calculator looks like it's going to be 55 times 365. Let me go back to that. 365.25 times 24 times 60 times 60, and that'll give me my seconds. So let's break that into my calculator. We have 55 times, and then I have 24, and it looks like I have 1,735 668,000 seconds. Let me try that again to make sure I didn't make any mistakes. Yep, so that looks like lots of numbers. So this turns out to be 1.735 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the 9th seconds. How did I get the 9th? I counted from the end, which is where my decimal place was. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1.7 times 10 to the 9th. I add a 1 with 9 zeros. You can see them over here. And that'll give me the answer I need in scientific notation. 1.735 times 10 to the 9th. Now your answer would be the same thing, except you're going to substitute probably your age for whatever it is that you are age-wise. Probably 12, 13, somewhere in there. 43. That's it. We'll see you guys all tomorrow.